Well, one thing is, I'm really fascinated. I think of myself as a pretty savvy person and not easily led into false dogma. And yet, this is such a strange idea. And so it's basically a plea for help. It's not a cult. It's not that I want you to join me in believing in this. It's that this is so outlandish that join me as a scientist would join a research team, and let's cut it to pieces and show that it was simply a misunderstanding of information theory coupled with bad mathematics spliced onto a weak ontology or something like that, you know. Because this I could live with the time wave if I only had to read about it in Time magazine and that it was being developed by Negroponte and Prigozhin. The thing that sets up the cognitive dissonance for me is that I, from the point of view of most people, thought it up. And I am so aware of my limitations that to me that's the strongest argument there is, that it's malarkey. You know? And yet that's not a fair argument against an idea. In rhetoric, that's called the ad hominem argument, the argument to the man. That's when you get up and say, well, we shouldn't follow Jesse Helms because he's short and ugly. You know, that's not allowed. That's a below-the-belt move. And then I read books like Thomas Kuhn's The Structure of Scientific Revolutions, and it says, you know, this is how it happens. Some guy, marginal, not at the center of the field, and somewhat at loose ends, but usually with a broad education, gets it, you know. I mean, it happened to Einstein. He was a telegrapher. It happened to Alfred Russel Wallace. He was a surveyor who couldn't make a living, and so he went to Indonesia to collect butterflies for the British Museum. And we could multiply these examples ad infinitum. So, but I have spent a lot of time educating myself about what it would mean if this were true. In other words, how big a revolution is it? And it's an enormous revolution. The implications are staggering. For example, if it's true that time is a fluctuating variable, as this so strongly argues, then science as practiced for the past 500 years is out the window, because that kind of science is based on the concept of experiment. And experiment has built into it the concept of what's called a restoration of initial conditions. That means you can go back to the start and run the experiment again. This is saying, as Heraclitus said, you never step into the same river twice. And consequently, the idea of repetitive experiment is shown to be intellectually bankrupt. You could almost say, pardon me?
Scientists have already have recognized that.
Well, some have and some haven't. The idea that you would specify in a physics experiment that it should be done only when the moon is in Scorpio to obtain the correct results would get you...
But those experiments are primarily Newtonian in orientation, are they not? I mean,
well, give me an example of a time-dependent physical experiment recognized by science.
I mean, you know, dropping a ball out of the Tower of Pisa.
Well, it doesn't matter what time you do it.
Precisely.
That's my point. That's my point. That we could almost say of science that it is the study of those phenomena so crude that the time in which they occur does not affect them. And so falling balls, gas diffusion, simple things it doesn't matter where in time they occur, but things like the building of an empire, the waging of a war, the evolution of a species, the conquest of a biome by a new set of genes, these things, timing is everything and dictates success or failure. Did you want to say something?
Yeah, that's a very interesting point, because the anthropic, the Greek anthropic cosmological principle argues that life evolved at about the right time. If things had started up a little bit later, a little bit sooner, at least around this sun, it wouldn't necessarily have gotten a kickstart. The conditions were no longer quite right. The incubator was set to just the right temperature when the gases were at just the right concentrations and so on. And Stephen Gould has pointed out that we couldn't even play the tape over again if you started off with life at one of the early conditions 3.5 billion years ago and then ran it forward again. We wouldn't have ended up with people, and we wouldn't have ended up with the kinds of species we have. There are too many bifurcation points that can take place along the line. So there's actually 2 points there.
Yes, well, this is essentially what this is saying. Ordinary science says that evolution proceeds by the random mixing of genes, then subject to natural selection dictated by environmental parameters. And out of that, you do get a creative advance, or an advance into morphological complexity, but very slowly. And I think that what the time wave shows is that the deck, the cosmic deck, is stacked in favor of novelty, so that it isn't a 50-50 every time you throw the dice, that it's going to go toward entropy or order. Actually, order is favored, and so order emerges and is conserved over time, or novelty. I prefer the term novelty because to me chaos doesn't signify disorder. I view it in the new way. Well, anyway, maybe that's enough about that. I didn't intend such a long opening statement. It must be this coffee.
What you were saying sounds like, I think it was just recently, a couple months ago, the Hubble constant, the Hubble telescope was throwing things into question, and, I think, have you pursued that?
Yes, I follow all that very carefully. I touched on it in my lecture by implication last night. It was in my mind when I said how so much of science recently has been about answering the question, when? When? There is huge controversy raging at this moment in astrophysics because, well, here's the background. In the 1920s, Edwin Hubble studied variable stars, and in an effort to establish what are called absolute or reliable candles for measuring cosmic distance, knowing that if he could very accurately calibrate the radiance of this certain type of star, that then he could calculate how that radiance would diminish at distance. And there is a number involved with Hubble's name called the Hubble constant. And if you set it high, the universe is young. Did I get it right? And if you set it low, the universe is old. And furious battles are now raging because there is data coming in both from the Hubble telescope, ironically, named after Edwin Hubble. There is data coming in there that is supporting the idea, I believe, that using standard mathematics, the universe is young. In fact, paradoxically, younger than some of the oldest stars in it, which doesn't make a whole hell of a lot of sense. Conversely, from a different set of instruments, looking at a different part of the radio or electromagnetic universe, low Hubble constants values are coming in, implying that the universe is 18 to 22 billion years old rather than 6 to 8 or 8 to 10. And as far as the time wave is concerned, I was looking at this and I realized I should issue a press release and make a prediction and say that according to my calculations, the age of the universe is precisely X, and then see where these other people come down. I think the time wave favors the idea that the universe is about 17.5 billion years old. And that is in agreement with the data that does not contain an internal contradiction. I find the idea of a universe 8 billion years old almost as unlikely as a universe 4,306 years old. I feel real cramped in a 10 billion year old universe. That is not enough.
Well, I was just thinking that if the Hubble constant had a variation in time, that would probably describe it. Maybe your formulas might point to how it might vary in time. Or we have a locally varying Hubble constant.
Well, yes, you raise a whole bunch of interesting issues here. Look at how presumptuous science is. First of all of modern physics is based around the concept of constants. The central, and some of these are non-dimensional constants, but some are not, like the speed of light. Well, the speed of light has been measured on this planet since 1906. Less than 100, just under 100 years of measurement in a multi-billion-year-old universe carried out on one planet. And from this, you make the grand statement that the speed of light in all times and all places will obey this law of velocity? Give me a break. It's just a kind of a joke. And yet, to admit that there is a problem here would seriously undermine the premises of science. Things are worse than that. Throughout the 20th century, of course, the speed of light has been measured many, many times. Now, the same value is rarely obtained. Now, all of physics depends upon this being a universal constant. So when you point out to them that the same value is rarely obtained, they wave their hands and say, well, this has to do with the limits of the instrumentality, a term which will not be further defined. This has to do with the limits of the instrumentality, and they're just hitting around it, right? So at first you, the uneducated layman, you think, well, that makes sense. I suppose they're just hitting around it. But then you go back and you look at these measurements of the speed of light, and you know what? They don't cluster around a point. Since 1906, successive measurements of the speed of light seem to imply that it's incrementally going slightly faster. The set of data points is drifting slightly across the thing. Well, now, how, if it's at the limits of the instrumentality, can you possibly explain that? Well, this became such an issue in the astrophysics community, and check this out, that what they did is in 1972, they defined the speed of light. and they said, this is the speed of light. And all future calculations should use this number regardless of what the instruments are telling you. A momentous turning point in the evolution of scientific thought. At last, nature itself is deemed no longer necessary for the study of nature, and in fact, it just gets in the way. Anyway, I can go on at great length about the foibles of science, but...